Since elementary school, this has been your mental image of home. A nice, orderly neighborhood, small rocky planets on the inside, an asteroid belt as a fence, and big gas giants in the backyard. It's predictable, it's stable, it's normal. For centuries, science relied on the Copernican principle, the idea that we aren't special, and therefore, the rest of the universe should look pretty much like us. But in 1995, that assumption shattered. We found our first sun-like star, hosting a planet 51 Pegasi b, and it was a monster, a gas giant bigger than Jupiter, orbiting closer than Mercury, whipping around its sun in just 4 days. We thought it was a fluke, but as the Kepler Space Telescope began staring at the galaxy, the data became undeniable. The universe is full of chaos, violence, and bizarre planetary arrangements. Our solar system isn't the blueprint, it's an anomaly, a cosmic accident. Today, we explore the terrifying evidence that our stable, life-giving home is actually a freak of nature. When astronomers take a census of the Milky Way, one type of planet dominates. They are the middle children of the galaxy, worlds significantly bigger than Earth but smaller than Neptune. We call them super-Earths. Statistically, they are the most common type of planet in existence. Roughly half of all sun-like stars host at least one. But look at our system. We have an immense gap in that exact size range. It's like walking into a shoe store that stocks every size except a men's 9. It makes no statistical sense. Scientists now believe our system is hollowed out. In its infancy, the building blocks for those super-Earths existed right here. But something violent happened to clear that material out, leaving us with a strange empty void where the galaxy's most common planet should be. To find the culprit, we have to look at the gravitational bully of our neighborhood, Jupiter. This is the Grand Tack hypothesis. 4.5 billion years ago, our system was filled with a thick protoplanetary disk of gas. As a young Jupiter grew, drag from this gas caused it to lose orbital energy. Jupiter began a death march toward the Sun. In most other systems, this ends with the giant becoming a hot Jupiter, incinerating everything in its path. Our Jupiter acted like a cosmic wrecking ball. It plowed through the inner solar system, smashing apart the embryonic super-Earths that were trying to form there, sending their debris spiraling into the Sun. Jupiter was on a path to clear the board completely. Earth never would have formed. But then, Saturn arrived. As Saturn grew, the two giants drifted into a specific orbital resonance, a gravitational walk step, where Jupiter orbited 3 times for every 2 orbits of Saturn. This cosmic tug-of-war acted as a gravitational brake, reversing Jupiter's course and towing it back out into the dark. We exist because a wrecking ball turned around at the very last second. But Jupiter's rampage left a permanent scar. We call it the Mars paradox. According to standard planet formation models, based on the amount of material that should have been available at that distance from the Sun, Mars should be roughly the same size as Earth or Venus. Instead, it's a stunted, frozen runt. Why? Because when Jupiter migrated inward and then back out, it passed right through the zone where Mars was forming. Jupiter essentially starved Mars. It swept away the building blocks Mars needed to grow into a full-sized world. In a normal solar system, Mars might be a lush, massive habitable twin to Earth. In our freak system, it's a withered testament to Jupiter's near miss. The chaos didn't end there. Long after the rocky planets formed, the outer system underwent a violent spasm known as the Nice model. Through complex gravitational interactions, Uranus and Neptune were shoved outward, plowing headlong into the ancient Kuiper belt. This destabilized trillions of icy comets, flinging them wildly throughout the solar system. This triggered the late heavy bombardment. For millions of years, the inner planets were subjected to a rain of cosmic shrapnel. While terrifying, this might have been our salvation. many scientists believe Earth formed too hot and dry to support life. These icy comets, flung inward by the migrating giants, may have delivered the vast majority of the water that fills our oceans today. Our freak planetary shuffle might be the only reason Earth isn't a dry desert. Finally, there is the matter of order. When we look at exoplanets, we often see high eccentricity, planets with wild, stretched-out oval orbits. On these worlds, the climate swings wildly from boiling to freezing in a single year. The evolution of complex, delicate life would be nearly impossible on such a climate roller coaster. Our planets, however, move in freakishly perfect circles. This rare circularity acts as a long-term climate anchor, providing the billions of years of relatively gentle stability required for life to crawl out of the oceans. So, what does this all mean? It leads us to something called the anthropic principle. We shouldn't be surprised to find ourselves in a freakish, incredibly rare, stable solar system. Because if our system wasn't this weird, if Jupiter hadn't turned around, or if our orbit was eccentric, we wouldn't be here to notice it. When you look up at the night sky, don't assume you are looking at more of the same. You are looking at a violet, chaotic wilderness, and you are standing in perhaps the only safe harbor for thousands of light years. We are not the standard. We are the lucky ones. If you enjoyed this journey through our strange neighborhood, subscribe and join us as we explore the furthest reaches of the universe.